everyone. This video will show how to solve classic mixture problem. Let's go over this example. A juice vendor has two types of apple concentrate. One that is 80% apple concentrate and the other is 30% apple concentrate. How many liters of each type should he mix together to obtain 40 liters of apple juice that is 40% apple concentrate? To better see this problem, we're going to go ahead and draw a picture for this problem. So I'm going to go ahead and draw this bucket or this cup for, let's say this is juice A. So I'm going to label this as juice A. So in juice A, we say that this is 80% apple concentrate. And then we are going to have this bucket for the mixture on both of them. So I'm going to go ahead and label this as the mixture of both A and B. Well, the other type of apple concentrate that we have here, we will label this as B, and it's going to be 30% apple concentrate. So this is 30% concentrate. The vendor is supposed to mix them together. Concentrate A will be mixed together with concentrate B. So the two juices will be mixed up together. It says here that the mixture should be 40 liters together. So this one right here should be 40 liters. And the concentrate for this mixture should be 40%. So we're going to have 40% apple concentrate. Now looking at this, we are missing the volume for juice A and the volume for juice B. So we can just go ahead and label this as blank liters. We don't know what that is. And how many liters of B will be mixed to come up with 40 liters, that is 40% apple concentrate. So this is the picture for this problem. Now we're going to organize this data in a table form. So I'm going to go ahead and draw the table on the side here. So I've set up the table here. So there's type of two juices here, juice A and juice B, and then the mixture. So in this problem, we are given the amount of the mixture is 40 liters. So I'm going to label this as 40 right here. And we don't know the volume for A and B, so we can go ahead and have this as X and Y. And then the concentration for both of these, for A, we say that this is 80%, so I'll write that down here. And then for B, that's 30%, I write that down here. And then the mixture for them, when they're combined together, is 40%, so I'm going to write that down here. And we're going to change this concentration into decimal. So we just have to divide this by 100. So this is 0.80 or 0.8 should be okay. 0.30 or 0.3. And this is 0.40 or 0.4. And for the content, we are multiplying this column. That is the amount and the concentration. So that would represent the content. So in this case right here, we will have 0.8x. So we're multiplying these two. And this would be 0.3y. Again, you can use 0.80 or 0.30. It doesn't matter. And then for this one here, 40 times 0.4 is 16. Now, to solve this problem, we're going to use these two equations. That is the equation for the amount and the equation for the content. So the two system of equation that we have here would be, so this will be the two equations that we're going to use to solve for X and Y. So let's go ahead and solve this equation right here. So I'm just going to go ahead and rewrite this equation on the side here. So we're going to use elimination method to solve for the X and Y here. So the first thing that we need to do is we will eliminate X first. In order that we can do that, now looking at this, their X values are not the same. However, I can multiply the first equation by whatever is this value, that is the coefficient of X. I will multiply this by 0.8. So that means each of these is going to get 0.8. And then I have to multiply the second equation by the coefficient of the first one, which in this case is 1. And it doesn't really matter. Anything multiplied by 1 is the same thing. So we go ahead and this equation would come out multiplying each one of these. So 0.8 times x is 0.8x plus 0.8 times y is 0.8y, and that is equal to 0.8 times 40 is 32. And then we keep the same thing because it's multiplied by 1. So we go ahead and subtract these two equations together so that we can eliminate x. So in this case right here, this is eliminated. And so we have 0.8 minus 0.3 is 0.5y, which is equal to 32 minus 16 is 16. So we're dividing 0.5 from both sides so that we can have y by itself. So 16 divided by 0.5 is 32. So in this case right here, the farmer needs to pour in 32 liters of juice B, that is 30% concentrate, to create this mixture. Now to solve for the volume for juice A, all we need to do is just to use one of these equations and solve for x. So in this case right here, we can use the first equation. So that would be x plus y equals 40. We already have the y, which is 32, so we plug it in. So x plus 32 equals 40. So we're going to subtract 32 from both sides, minus 32, and that would give us x is equal to 8. So this means that the farmer would need 8 liters of juice A to come up with 40 liters of 40% mixture. Now notice that if we have here 8 for juice A and then we have 32 for juice B, adding them together, 8 plus 32 will give us 40. So that is how we solve this classic mixture problem.